This is another nice report from the IEA, International Energy Association, I guess, whatever it stands for, I forget, but um, International Energy Agency, yeah. It's nice, but it's also very long, so I'm going to be very brief as usual because I'm not, covering these reports in great detail. I give enough pointers as introduction so that if you are interested in the details, you can follow up. This says energy and AI. It has, AI is going to use a lot of energy because now AI is also being used in everything from mining to energy production, fossil fuel production, managing energy systems, data centers, grids, homes, appliances, everything, right? So it's a nice problem to think about because AI is here and it's going to be here forever. Let's read the executive summary. I will need at least 2 podcasts for this one, so maybe we'll read the executive summary without rushing it and then do 2 more podcasts of each chapter. Each chapter provides nice summary points that I'm going to read off as well with just a couple of figures. There are a lot of figures, incredibly good amount of data with some projections out to 2030, but since the summary points are so nicely put together, I'm going to skip showing too many figures. Okay, the transformative potential of AI depends on energy. So AI itself needs energy. There has been a step, computational power as well, data storage. There has been a step change in the capabilities of artificial intelligence driven by falling computation costs, a surge in data availability, and technical breakthroughs in terms of the techniques for AI. AI is the science of making machines capable of learning to perform tasks that traditionally required human intelligence. We have discussed AI, types of AI, etc. already, so I'm going to skip that part here. AI is emerging as a general purpose technology, much like electricity. Today it can generate text and videos, accelerate scientific discovery in fields like medicine or material science, make manufacturing robots smarter and more productive, drive commercial taxis in complex city landscapes, and detect threats to critical infrastructure, right? So even read x-rays. There are billion applications. In the past few years, AI has gone from an academic pursuit to an industry with trillions of dollars of market capitalization and venture capital at stake. The market capitalization of AI-related firms in the S&P 500 has grown by around $12 trillion since 2022. I'm recording this in June 2025. The report just came out. So in just a couple of years, it has now grown to $12 trillion. While there are several uncertainties about its uptake and impact, AI's rapid development and huge potential have made it central to corporate strategies, economic policies, and geopolitics. And we'll look at uptake of AI in the energy sector and see when it's not taken up, when it's not integrated, then there are reasons why that is so. So we'll look at some examples of that. However, there is no AI without energy at the same time, and AI has the potential to transform the energy sector itself. Affordable, reliable, and sustainable electricity supply will be a crucial determinant of AI development, and countries that can deliver the energy needed at speed and scale will be best placed to benefit. Training and deploying AI models takes place in large and power-hungry data centers. A typical AI-focused data center consumes as much electricity as 100,000 households, but the largest ones under construction today will consume 20 times as much. So it's an energy hog, water hog, and of course we are trying to save everything now, including our messages, emails, images, videos, travel photos, etc. So this is going to just keep growing super exponentially. Policymakers and markets have lacked the tools to assess implications. The energy sector is therefore at the heart of one of the most important technological revolutions today. We don't have to think too much about how important it is, but based on a new global model and comprehensive data set of data center electricity demand, its analysis was also enriched by an in-depth process of consultation with policymakers, the tech sector, the energy industry, and other experts. So the IEA has done extensive analysis here. It's really a nice report, and maybe someday it will be just serving as a part of a big course by itself, and there is enough information for that. Data centers account for a small share of global electricity consumption today, but their local impacts are far more pronounced, and I have elsewhere mentioned the battle in Virginia, USA for locating a data center, I think by Amazon, in their neighborhood. And initially they thought, wow, this is income and employment opportunities, but then they began to impose on electricity and water, and now people are not sure this is a good idea. Global investment in data centers has nearly doubled since 2022 and amounted to $500 billion in 2024. Data centers accounted for around 1.5% of the world's electricity consumption in 2024, or 415 terawatt hours. Okay, and then there are countrywide numbers as well. We look at the example of India and how it's growing in data centers and how its energy supply is growing as well. Okay, so obviously making energy for AI carbon free will be very critical, considering the demand for energy by AI itself. Electricity demand for data centers more than doubles by 2030 in the IEA projections. Data center electricity consumption is set to more than double to around 945 terawatt hours by 2030 from 415 terawatt hours in 2024. So obviously US, China are leading it, Europe as a whole is leading it, India is trying to catch up, and there are other players in this as well. And by the end of the decade, countries, US is set to consume electricity for data centers, more electricity for data centers than for production of aluminum, steel, cement, chemicals, and all other energy intensive goods combined. And you hope AI will save energy for all these other productions, but if it needs so much energy, then it better be saving a lot of it. Okay, so the number is, the base case sees global data center electricity consumption rising to around 1200 terawatt hours by 2030. A diverse range of sources will be needed to meet the demand. No need to really state it, but it's obvious, but still you have to say it. Renewables and natural gas take the lead in meeting data center electricity demand, but a range of sources are poised to contribute. Okay, so the major players themselves, Microsoft, Google, Apple, Facebook, etc., Amazon, are trying to crank up their own energy sources, renewables, nuclear, and so on, to meet their own cloud requirement, data center requirements, which obviously has lots of AI in it as well. So modular reactors can come around, are expected to come online around 2030. So you can see that energy solutions are now being driven by data centers rather than climate concerns. That's kind of interesting, right? Data centers are one of several drivers of accelerated electricity demand growth in the age of electricity. Data centers account for around 1/10 of global electricity demand growth by out to 2030, less than the share from industrial motors, air conditioning in homes and offices, or electric vehicles. However, the significance of data centers is growing rapidly, and as we said, the electricity demand growth is going to be more than 20% by 2030, going from 1/10 of the global energy demand. 1/10 of the global electricity demand. Smarter is faster when it comes to integrating data centers in electricity grids. Electricity grids are already under strain in many places. Spain and Portugal had a massive failure recently, and that was blamed on combination of renewables and grid not being designed to handle intermittency and so on. We estimate that unless these risks are addressed, around 20% of planned data center projects could be at risk of delays. So, as I said, energy demand is now, energy solutions are now coming more from data center demands rather than from climate change aspects. Key options to mitigate these risks include locating new data centers in area of high power and grid availability, and operating either data center servers or their on-site power generation and storage assets more flexibility. And there are a lot of plans being made by private players themselves, because they're not going to rely on utility companies or the government and try to generate their own energy to meet their own demands, because they are being too heavy on the existing grids run by other utility companies and so on. Okay, we find that 50% of data centers under development in the US are in pre-existing large clusters, potentially raising risks of local bottlenecks in energy supply, production, and energy transport, right? Transmission, sorry, in this case. There are large uncertainties in the outlook for AI-related electricity demand. There are uncertainties in how quickly AI will be adopted, how capable and productive it will become, how fast efficiency improvements will occur, and whether bottlenecks in the energy sector can be resolved. So we won't go into the numbers there, but there are projections. By 2035, the range of data center electricity demand across our cases, which they considered here for projections, range from 700 to 1700 terawatt hours. The increase in gas-fired power to meet data center demand in our liftoff case is 4 times higher than in our headwind case. Growth in nuclear output to meet the data center demand varies even more. So liftoff and headwind obviously depends on how policies and incentives or markets are allowing data centers and AI to grow, and how fossil fuels are being phased out. And headwinds means you will have a lot of opposition for phasing out fossil fuels, and policies will not favor renewables, maybe, as is happening in the US right now. AI could unlock major efficiency and operational gains for the energy sector. AI is already being deployed by energy companies to transform and optimize energy and mineral supply, electricity generation and transmission, and energy consumption. There are obviously many objectives in play, economic considerations like reducing costs or increasing supplies, and asset lifetimes and downtimes, and lowering emissions, intermittencies, storage, etc. are all going to play a role. The oil and gas industry has been an early adopter of AI, using it to optimize exploration, production, maintenance, and safety. So using AI to produce more fossil fuels is going along with using AI for managing, producing, and using renewable energy. AI can also help to balance electricity networks that are growing more complex, decentralized, and digitized. The industry of the future will be increasingly digitalized and automated. Countries and companies that take the lead in integrating AI into manufacturing will jump ahead. Obviously, AI applications in transport can improve efficiency and save costs, but it could also increase demand for personal mobility. So you can see how energy production, AI for managing energy production, and AI for managing other socio-economic and climate action issues like transportation are all going to come together in some ways, including people's need for personal mobility as opposed to relying on ride-hailing or public transportation and so on. In buildings, there is significant potential for AI-led optimizations to make heating and cooling systems more efficient and electricity use in buildings more flexible. Okay, so accelerated innovation could be one of the most significant longer-term impacts of AI on the energy sector. Yes, game changers may come along, or innovations might just begin to grow exponentially. AI is emerging as a powerful tool for scientific discovery, helping researchers to find, test, and commercialize innovations faster. Energy innovation challenges are characterized by a kind of problems AI is good at solving. For example, only 0.01% of the next generation solar PV materials have been experimentally produced, leaving a huge set of possible materials still to be explored. AI could allow scientists to dramatically accelerate the process of finding and testing promising materials, including battery chemistries and carbon capture molecules. Of course, there will be needs to have policies and commercialization, market management, etc. Energy sector is not yet making the most of AI. So AI is capable of many things, but we are still not ready for it. And there are reasons why some corporations haven't even started using AI, and we'll see why that is, what barriers and gaps exist. Energy is the most in the US you would say energy is amongst the most complex and critical sectors in the world today, yet it can and should do more to seize the potential benefits of harnessing AI. AI should sharpen some energy security concerns and help address others. The supply chains for the components going into data centers are complex and globalized. Our estimates indicate that in 2030, demand for gallium, for example, for data centers could reach over 10% of today's supply. 10% of the total supply could just be for data centers. AI compounds some energy security risks, but it also offers solutions in both the cyber and physical domains. So cyber security is going to be a big part of managing AI, use of AI in running everything, because if you get hacked, then the entire system can be broken down. As the nature of energy security evolves, the IEA will continue to monitor this critical issue. Emerging and developing economies can leapfrog to AI solutions. Emerging and developing economies other than China account for 50% of the world's internet users, but less than 10% of the global data center capacity. Okay, so India and other developing countries, in addition to China, are really wanting to grow not only in energy production but also in AI itself, and using AI for all these sectors that we mentioned. Concerns that AI could accelerate climate change appear overstated, as do expectations that AI alone will address the issue. So AI, energy use, and clouds, that an autonomous car is basically a cloud on a wheel. Clouds require a lot of energy, as we just said, but how will we manage the energy supply for the clouds? Will they be run on the batteries in the car that themselves are recharged with renewables, in which case maybe we don't have to worry about impacts on climate change? And so there's a complicated list of issues there. Emissions from electricity used by data centers grows from 180 million tons today to 300 million tons in the base case by 2035, and up to 500 million tons in the liftoff case. I'm being lazy about not reading about what is liftoff case and headwind case, but you can go and read it, but you get intuitively what it is. They are projections and they are assumptions about how the system will allow it to lift off and take off like a rocket, or face headwinds and slow down. So the widespread adoption of existing AI applications could lead to emissions reductions that are far larger than emissions from data centers, but also far smaller than what is needed to address climate change. Is it being a little optimistic? Maybe, but it's better to be optimistic about the future anyway. But AI can be a tool in reducing emissions, but it's not a silver bullet and does not remove the need for proactive policy. So phasing out fossil fuels, especially coal, reducing emissions, electrification, efficiencies, decarbonization, everything have to go on. AI is not going to solve everything, right? With energy and tech now on a journey together, collaboration is key. The tech sector and energy industry are more intertwined than ever before. Okay, that's obvious. So The IEA will continue to provide data and robust analysis to inform decision making and help the energy and technology sectors be better prepared as the adoption of AI unfolds. Okay, so this is just the executive summary. Let's see how long I have gone. 20 minutes, so maybe it's a good time to stop and then read the rest of the chapters, which will be longer because I will read all the summary bullet points to get a better sense of what the rest of the report actually involves or includes and what information is really important. Each chapter is long with lots of figures, data and projections, etc., that I'm not going to read, but summary points will give us a good sense of what we are talking about. Okay, maybe I'll do one more before I have to run to another meeting then.